Hello, everybody. There is one topic that I've had quite a few questions about, or a couple questions anyway, representing solutions on a number line. Now, this is a supporting part of the TEKS. A supporting TEK would be those things that we have learned in some form or another in a previous grade, which are going to assist us with our current readiness or TEKS that are the most important that the state deems, that are the things that we definitely need to know and need to practice and be able to show our knowledge of very well. Now, as you notice, representing solutions on a number line, it is just an offshoot of solving equations where we can plot our answers and interpret them on a number line. So what we're going to do at this moment, I'm going to go ahead and switch over to our work, and I'm going to show you what that looks like. All right, as you notice here, I now have up my examples. This is going to be TEKS 7.10b, representing solutions on a number line. That's part of what the official TEKS would say, but this is that number that you look at. If you're going to look in the book, go to the table of contents and actually click on 7.10b, and it'll take you to more examples. Some of the examples I am actually taking directly from the book. This is -3t plus 9 is going to be greater than or equal to -21. So what I'm going to do is I'm going to go ahead and solve this, and then I'm going to show you what exactly, how I would show it on a number line. Okay, first things first, I'm going to use the additive inverse to add -9 to both sides. This becomes -30 is greater than or equal to, that is -3t is greater than or equal to 30. When I divide by a negative coefficient, remember that means that my sign will flip. I'm going to take my work over here so I won't run into my number line. -3 divided by -3 becomes +1, so that is now t. I'm going to flip my sign, less than or equal to -30 divided by -3 would be a -10. Now I want to make an appropriately sized number line. So what I'm going to do is I'm going to start this off here in the middle with 0. I have 2, 4, 6, 8, 10, 12. I'll take this out to 12. That's positive on the right. I'm going to 1, 2, 3, 4, 5, 6 tick marks. That would be -2, -4, -6. I'll do -8, -10, and -12. Okay? So now I want to go ahead and plot this on my number line. I need a solution to t, or a value of t that is less than or equal to -10, less than or equal to -10. So what I'm going to do is I'm going to take my red pen. I'm going to draw a closed dot. Now, why would I draw a closed dot? An open dot means solution is not included in this value. And then a closed dot means solution is included in this value. Okay, and I apologize for my handwriting. All right, so now I know that if my solution is included in this value, because again, it is less than or equal to, I'm going to draw my arrow this way for my solution. So again, less than or equal to or greater than or equal to would have a closed dot. Less than or greater than would have an open dot. Okay? Now, that's going to come in handy when we look at an example down below. All right. So next, and again, my solution is there. I'm going to start with this one. Again, I'm just going to go through and solve my equation. Now, if you would like more in-depth information about solving a two-step equation, there are videos there in my listing that you would do if you're confused by this. But I'm just going to go ahead and go through and actually solve. That's less than, that is 44, because when I subtract 5 from 49, it gives me 44. I am going to go ahead and divide both sides by 2 because my coefficient is a 2. This becomes S is less than 22. Now, you might ask yourself, why didn't you flip the sign like you did before? This coefficient is not negative. The only time you do that with an inequality is if it's negative. Now, I'm going to make an appropriately sized number line. I don't always have to start my number line with 0, or 0 doesn't always have to be there. Okay, so I want to start my number line, say, with 25 maybe. Sorry, it should be a line, not a dot. Line, not a dot. Okay? 4. Okay, so let's just start numbering. Okay, so we have numbered all of our lines. Now, I want to represent a solution that is less than 22. So I'm going to start with 22 and keep my dot open because remember, less than has an open dot. Okay, I'm going to draw my solution, and I probably should get a different colored implement so you can see a little bit better. That doesn't do much better. Okay, I'm going to try this. Maybe that will work better. Yay, that works better. Okay, let me go ahead and do this one again for you. So that looks a little bit better. Okay, so you can see it. All right, now that is an open dot. That is solved. Okay, so any value that is less than 22 would satisfy this inequality, just like any value that includes negative 10 that is less than, so if the value of t is less than or equal to negative 10, all of those values would be included. That's into infinity that way, into infinity that way. Okay, now I'm going to go ahead and solve one more time. That's 7. I'm adding 7 to both sides because this is a negative. Okay, that becomes positive 48. 6m is equal to, well, wait a second, Mr. Moore. That's an equal sign. What do I do with an equal sign? Okay, when I divide 48 divided by 6, it gives me 8. So again, appropriately sized number line. All right, I have, say, 0, 2, 4, 6, 8, 10, 12. Now, how do I just represent where the value of m is equal to one thing? Okay, when you have an equation, it's only equal to one thing. Now, at this point, I'm just going to do something very artistic. Okay, that was a joke. One dot, one closed dot, because my value is included with negative 8. It is only negative 8. It doesn't go that way, all my solutions. It doesn't go that way. It's just one solution, just one closed big dot. Okay, it's 8. And that's pretty much it. You're solving the equations and representing it with a number line, and that's that. So, any other questions, please come to me in class and ask. I'm going to give you a full pan of this. Okay, come to class and ask me. Come to tutorials on Tuesdays or Thursdays with me. And as always, I will see you tomorrow.